Would you like me to begin? What questions can I answer? 14. All right. So number 14 was the problem about the study time and exam scores. So it says after the first exam, 14 students that were surveyed their data was collected to determine the relation between amount of time spent studying and the exam score. The professor found that the linear relation that exists was this guy. So this was given to you. So that y hat with those particular values for the least squares regression line. It asked you first to predict the exam score of a student who studied for 2 hours. So that's just plugging in. So plug in 2, get the result, and then list that as the score. We aren't told, whether it's a percent, whether it's points. So I'm okay if you don't have a label. I'm also okay if you guessed at a label, but it wasn't given in the original problem, so that's kind of up to you. Part B asks you to interpret the slope. So again, yours doesn't have to be exactly like mine. There are lots of different ways to correctly state an interpretation of the slope. But slope, because it is, typically rise over run, right? And no matter what situation we're looking at, rise, because it's a vertical change, is a change in your y value. The run is a change in your x value. So when you have slopes that are given as decimals, like this guy, 6.3 repeating, what that is telling us that it's 6.3 of the y's for every 1x. So that's essentially what I've done, is just put the labels for y and x. And the order that you state them is not important. So I said for each additional hour of studying, so that means for every plus 1x increase, it is important when you interpret that you say whether it's, positive or negative, so increasing or decreasing. We increased 6.3 repeating, exam points, and then on average. Because, again, y hat, one of the ways it helps us is by giving us that average increase or decrease. Part C asked what the mean score of students who did not study was. So remember that these least squares regression line, they have 2 purposes. And if you look at, I'm trying to find where it was on the notes. So this would be if you're looking at example 2C versus D. So this asks you to predict the mean distance for this particular x value. Part D asks you to find a specific distance for a particular x. Both of those are doing the same thing. We're just plugging it in. So didn't study means 0 studying. So it's asking you if x is 0, what is y? So in this case, that would be at your y-intercept value. D, a student who studied for 5 hours scored an 81. Is this above or below the average of all students who studied for 5 hours? So again, one of the things that the least squares regression does is it predicts the average for that x. So if I plug in 5, the result that I get is the average for all students who studied for 5 hours. This value is bigger than 81, so hence that particular student scored below the average for people who studied for 5 hours. What else? 20? All right, so 20 was one of the ones where you were given data, so obviously that needs to be pulled in StatCrunch. So this one was data for the length and weight of American black bears. So it said the data represents the lengths of 12 American black bears, so length, weight for 12 different bears. It asks you to find the least squares regression line, treating total length as explanatory and weight as the response. So I've written out the equation here that you get. So the 1.6942x minus 142.4709. This I pulled directly from StatCrunch. So just like I showed you in example 2 yesterday, you need to go in to StatCrunch and make sure that you're selecting the variables in the right order. So you're going to stat and then regression and then selecting simple linear. So it says that explanatory is length. So you should choose length for your X and weight for your Y. And StatCrunch will spit this out at the top. Remember that when it spits it out with the words. It's totally fine if you wrote it with the words here instead of Y and X. That's okay. Just make sure, remember that the hat symbol always goes over that response variable. So if you're using the words, make sure it's got a hat over it. That's what indicates that to people, just by looking at it, that it is a least squares regression line. B asks you to interpret the slope and y-intercept. So again, we're basically just putting the labels for X and Y, and we're saying for each 1X that it goes up, this is what happens with the Y. So I said for each centimeter increase in length, because that's my X, the bear will gain, so that's increasing, gain is increasing, 1.6942 kilograms of weight on average. The y-intercept is negative, so that doesn't make sense in the scope of the model. You can't have a bear that has a negative weight. So we do not interpret the y-intercept because we don't have lengths of 0 centimeters, and we definitely don't have negative lengths, or negative weights, sorry. Part C asks you to predict the weight for 149 centimeter bear. So I did that by hand. I did show you yesterday how in that simple linear regression there's a spot for predict X. So that's totally fine if you used StatCrunch instead of plugging it in by hand. Part D, what is the residual of 149 centimeter bear? So residual, remember, is the actual value minus the predicted value. So for the actual value, I have to get that from the data. So 149 centimeters, there is a data spot. The weight is 85 of that actual bear that was measured and weighed. So that's actual is 85. Predicted is what I just got from part C. So when I plug 149 into my equation, I got 110. So actual minus predicted is how we find a residual. So the residual is negative 25 kilograms. Then it says, is that bear's weight above or below average for its length? It's a negative residual, which means it's below the line, so below the average. F. All right, I'm gonna see if it will let me zoom in on this. If not, I'll rewrite it because I'm not sure. Oh, there we go. All right, so 12F asked you to do the sum of the squared residuals. So in order to do that, and it did say, because all of this in 7 through 12, said by hand at the beginning. So that's why I've written out all the work here, because this section for problems 7 through 12 said to do by hand. So what I have here for columns, I have y, and then I have y hat, then I had the residual, and then I showed that I squared it. Down at the very bottom is the answer, which is 15 1/3. How I got that, the y values are the actual values from the table that's given to you. Because again, residual is actual minus predicted. So I just copied all the y values from the table. The y hat values are the values that I would get when I plug in the x's that are associated with these y's into my least squares regression line from, let me see which part, the one from part B. So again, if you selected points that are different than mine, your answer is going to be a little bit different here. And that's okay. So if you didn't get exactly 15 1/3, it could be because you picked different points in part B than I did. As long as you picked points that went through the center of the trend, you had approximately the same number of points above and below the line, then yours is fine. It doesn't have to be exactly like mine. Here's mine for point B. So I did 10-4 and 25-18. So the second point and the last point are the ones that I used. So this guy was my equation, 14/5 x minus 16/3. Again, your answer could be different and still be correct. You had to pick two of these points, again, trying to go through the center of the trend. And if it does that, then yours is fine and doesn't need to be changed. But regardless of what your equation is in part B, that y hat column, all I did was I said, okay, when x is 5, what would my equation give me for y? So I plugged 5 in. And the answer was -2/3. So I recorded that. Then I said, okay, on my line, if I plug in 10 for x, what does it give me? It gives me 4. So then I go and I plug in the next one, 15, then 20, then 25. So I'm plugging all those x's into my equation from part B and then recording the result in my y hat column. The residual is the y minus the y hat. So for the top one, 2 minus -2/3. So that becomes 2 2/3 or 8/3. 4 minus 4 is 0. 7 minus 8 2/3 is -1 2/3. So I got each residual. Then you have to square them all. So 8/3 squared, 0 squared, -1 2/3 squared, -2 1/3 squared. And I added them all up. Again, your answer might not be the same as mine if your equation is different. But if you've used that process, then what you've done is good. And it doesn't have to be the same as mine. For if the linear correlation coefficient is 0, what is the equation of the least squares regression line? So the least squares regression line would be y hat equals y bar. Here is why. Because when I am calculating the least squares by hand, it's y hat equals b1 times x plus b sub 0. B1 takes R and multiplies it times these standard deviations. So if R is 0, 0 times anything is 0. So that means that the entirety of the B1 value is 0. So y hat equals 0 times x plus b sub 0. So that drops out the x term. And if you look, let me pull from the notes. If you look at the formula for b sub 0, it's b sub 1, which, oops, I can't see it on here. I forgot I zoomed in. Sorry. So b1 becomes 0 because of the r, but if b1 is 0, then that means this part of b0 is also 0. So y bar minus 0 is just y bar. So then this becomes 0, this becomes y bar. So y hat equals y bar becomes the final answer. I did them in StatCrunch, so you can just do those summary statistics and then just choose both columns, and it can run them both at the same time. I mean, you could calculate it by hand. I guess technically there's only 6 values, but X bar and Y bar are both the means, but you wouldn't want to do the standard deviation by hand. So I use StatCrunch for all of it since I was using StatCrunch for the standard deviation. 16. So 16 is fairly similar to what you had in 14 in that, let me zoom back out here because now this is too big. So 16 was one where it gave you the least squares regression line, and it's really focused on the interpretation. So interpreting the slope, again, all you're doing is putting the labels on there. So what is your label on the x-axis? What is your label on the y-axis? Every time we interpret slope, it's like a script. We say for each, 1 unit of whatever x is measured in this case, it's measured in terawatt hours. Then you say whether it's increasing or decreasing or gaining, losing, whatever verbiage you want to use. In this case, the CO2 emissions increase because CO2 emissions is your Y label, and then by whatever the actual slope number is, so in this case 1.3491, and then we should always say on average. And again, it doesn't have to be word for word. You could start with on average if you wanted to, but you should include all of those pieces. B says Luxembourg produces 2.2 terawatt hours. China had 6,495 terawatt hours. Would it be reasonable to use this model to predict the CO2 emissions of a country if it produces 6,394 terawatt hours? Why or why not? So the big thing when it asks this type of question is, would the model be appropriate? Is you are looking at the values that you already have in the data. If the value they are wanting to predict for is way higher than the highest value or way lower than the lowest value, then you say no. In this case, the value they gave us is below the maximum and well above the minimum, so it's within the scope of the data, so yes, it would be appropriate. The last one, very similar to what I went over in 14D, so you have to plug in the value that they gave you, you have to find the residual, and then say how you would interpret that. So my interpretation, I just said the US emits less carbon dioxide than the average country with 4,282 terawatt hours, because the residual I got was negative. Any others from 4.2?